So second, let's talk about the effect of multiplying or dividing by a constant. Okay, so let's use the same numbers, because I am going to curve our test, and I'd like to see the comparison of what happens when we have this data, which we already have all the information on in your notebook about the mean, the min, the quartile 1, the median, quartile 3, the max, and the standard deviation was 20.9. So let's talk about what happens if I were to, instead of changing this 90% to 100, to get them to 100, let me think of how I could else get them. Like if I multiplied by, if I gave them all 10% back, maybe, or 11% back. Let me see. So 10% would bring that person up to a 99. I think I'm pretty comfortable with that. So if I were to increase everybody's score by 10%, that would mean I would want to add 9 to 90. I would want to add 7.8 to 78. I would want to add 7.3 to 73. I'd want to add 5 to 50 and 3.9 to 39. Right off the bat, I don't like these numbers. I don't think I would ever do this because I'm really helping out the person who scored the most, this person, and I'm helping this person out who needs my help the most. I'm helping them out the least. So I don't think I would ever really do this, but let's see what ends up happening with the mean and things like that. So let's calculate the mean. Okay, so when I calculated it, I got 363 divided by 5, which gave me a new mean of 72.6. So just what I was thinking. If you were to take 66 and add to it 10% of it, you would get 72.6. So if you multiply every single number by 10% or increase it by 10% across the board, the mean will also increase by 10%. The min went from 39 to 42.9. It increased by 10%. Quartile 1, let's talk about the median and the max for now. The median is going to be 80.3 and the max is going to be 99. All of these increased by 10%. If I add 4.45 to quartile 1 from the previous one, 4.45, I'm going to get 48.95. So let's take a minute and try to calculate what the median is between 42.9 and 55. I'm getting 48.95. So I have a feeling if I were to increase 84 by 8.4, which is 10%, I would get 92.4, and I bet you that's going to also be my quartile 3, between 85.9 and 99. If I average those two, 92.45. Okay. Just 92.4. I messed up in my calculator for a second. Okay. So right now we know the effect of multiplying by a constant is everything is going to be multiplied by that constant by 10%. Let's take a look at the standard deviation. I know this is time consuming, but when we calculated it before, we got 20.9. We don't have to recalculate that one again. You can use your notes from what you had done previously. Let's do the standard deviation of these new numbers. For some reason, it seems like it's going to be different, but let's see. So our mean is different, it's 72.6. So now I'm doing 42.9. Take away the mean, and then I'm going to square it. Okay, so if I do this math, I get negative 29.7, and when I times it by another negative 29.7, I have 882.09. So I think something might happen differently in here. Let's see what happens. Fill in the rest of the table. This is the variance. And then square root this, and that will give us the standard deviation. Okay. So my old standard deviation was 20.9. Interesting. If I find 10% of this and add it to it, I get 22.99. So it's not 10% bigger. So when I'm calculating this doesn't seem right because I made a mistake here. This should be 30976. And that will affect this number here to be 212234. 212234. And it works out to being 530.585. So the only problem with this is that using pen, I can't hide any mistakes that I get. It works out to like 23.0344, something like that. It's pretty close to this number over here, which was multiplying the standard deviation by 10%. If I were to look back on the last page, which I have, the standard deviation was actually found by square rooting 438.5. And if I were to leave that in my calculator and then find 10% of it and add 10% to it, it would give me 23.0344. This is just off because of rounding along the way. That's the only reason why that's off. So if we were to compare these things that occurred, you can see the mean. The mean increased by 10%. The min increased by 10%. Quartile 1, the median, quartile 3, the max increased by 10%, as well as the spread increased by 10%. Like I was saying before, it helped that 90 person out a lot. It didn't help that person who got a 39% out a lot at all, because they weren't getting a set number. They were getting a smaller amount of data, or a smaller amount added to it. So it spread out the data a little bit extra. So when multiplying or dividing by a constant, all data and calculations are increased or decreased if we were to be dividing by that amount. Mean, min, max, median, quartile 1, quartile 3, standard deviation. Even the interquartile range. If you look at the interquartile range between the original information, it looks like it's between 44.5 and 84, which is like 19.5. And I'm sorry, 39.5. I knew something didn't seem right. If you look at the difference between these two, it's about 43.45. If you take 39.5 and add 3.95 to it, which is 10%, you'll get 43.5. So when we look at the box plot for each one of these, this is the original data, and this is the data after it's been multiplied by 10%. And every piece has gone up by 10%. The max, the min, the median, the quartile 1, quartile 3. The interquartile range goes up by 10% because they're all getting 10% bigger, not really adding a constant number, but being multiplied by a percentage bigger. And if you look, you can even kind of see that the box looks like it's gotten a little bit longer here.